Well, good day again, Year 7s, and welcome to exercise 8C, where we're having a hopefully very quick look at dot plots and column graphs. Okay, so here's some stuff you need to put on your note-taking sheet. Um, some information here. So the first thing is a dot plot. All right, so a dot plot this is a dot plot over here. Okay, that's a dot plot. So basically a graph using dots, and the dots may indicate a certain value. So in this one, maybe each dot is worth 1, it could be worth 5, but generally they are just worth 1. It's a very simple way to show data. All right, so a dot plot can be used to display data where each dot represents one datum. Okay, it's usually just one data point. We've also got a column graph, which you can see down here. All right, column graph, and column graphs can not just look like this. Column graphs can also end up going this way also. Okay, so they can be horizontal and vertical in their design. All right, but column graph is another way to show data. In different categories, all right, and very often that's what the column graphs are used for, to show different categories or values, grouped values. So you might have each of these might be from 0 to 5, for instance. Again, that's not really drawing very well. And this one might be 6 to 10, and so on. Okay, so it can also sort of represent data that way as well. It's useful when more than a few items of data are present. Like in this case where you've got different colours and showing the different colours. Column graphs can be drawn, as I just said, vertically or horizontally. Graphs should have the following features, and we'll probably have a look at this in class and go over this a little bit. It's really important that you understand how to read graphs and all the information that is on a graph, because down the track when you do more graph analysis, this is years 9, 10, particularly VCE, depending on what type of subjects you do. You do need to be able to read graphs really accurately. So you do need a title, which is explaining what the graph is about. You've got two sets of axes, and these are the same axes as when we're looking at our number planes, where you've got your x-axis on the bottom and your y-axis going vertically. Each axis has a label, okay, so they're labelled, okay, giving you information about what each axis is about. So obviously in this case, the x-axis or the horizontal one is showing you the different colours or different groups, okay. And each of these obviously is called a category, and it has a category label, so that shows all the different categories you've got on this axis. And it's for the category stuff is non-numerical data, so it's stuff that's not necessarily numbers. And then on this side you've got what each bar represents, I suppose, or the amount each bar represents. So in this case, the number of students who may like red or green or yellow or blue or pink. Okay, so that's what that one represents. And you need to have all that information on any graph you draw. You need to make sure you've got a title. You've got to make sure obviously you've got your two axes. You've got to make sure your axes, each axis has a title in itself and a label. And you've got to make sure that all your categories are marked appropriately and correctly. All right. All right, so that's very quickly what a column graph is about. Any numerical axis must be drawn to scale. Don't have to worry about that too much, but when you look, and I'll explain this a little bit more down the track, but when you're drawing your graphs, particularly the numerical data axes, whichever one you have that, because in this case it's obviously a vertical one, but on a horizontal column graph, your numerical data will be on the bottom here, not on the y-axis, but on the x. But it's really important you look at the data you have, and because that determines what sort of scale that you have in your numerical data. So it might go up by ones, or the data might be something like 80 and 140 and 210 and stuff like that, which means you might end up going by 20s in your scale. Okay, so you've got to look at your data first and then decide what an appropriate scale is as you move up, and it's got to be the same. You can't have like 0 to 5, and the next one be 8, and the next one be 13, go up by 5 again. Like, they have to go up the same value. So in this case 5, 10, 15, 20. So you couldn't go 5 then 8 and then maybe 10, and then back to 15, and so each one's different. They've all got to have exactly the same value, otherwise it's not going to be an accurate graph. One other thing that you might come across too is like a little guy like this, where you've got most of your data sitting in here, okay, but you've got a little bit of data sitting out the side, and that's called an outlier. Okay, so it is a value that is distinct or away from or very different from the main cluster of data that you have. All right, so if you ever get data where you've got a nice little cluster of data in there, but you've got one little guy that sits outside of that and fairly clearly outside of that, if you put something, a dot here or even here, that's not necessarily an outlier, but sort of maybe from 8 beyond, you might class that as an outlier. Okay, so but it is just a bit of data that is very different from the main data that you have. All right. Okay, so hopefully that makes sense. So make sure you put that information into your note-taking sheets, and let's get on to some examples. Okay, so the dot plot below represents the results of a survey that asks some children how many pets they have in their home. So look at this very carefully. So we've got our title, so Pets at Home Survey. We've got our axes on this side being labelled as the number of children, okay, that have been interviewed, I suppose, okay, and down the bottom here you've got the number of pets. All right, so just to quickly go over what this means, it means that the kids have been asked how many pets do you have and how many, so in this case, for instance, no pets, so these kids in this column have no pets whatsoever, so how many kids, each one of these is like 1 point, okay, how many kids don't own a pet? So you just simply count them, 1, 2, 3, 4, 5. There'd be 5 kids that don't have a pet. You've got one kid out here, so here's our outlier, for instance. One kid has 8 pets, okay, and so on. So there's the number of kids that have 1 pet, 2 pets, and 3 pets, and so on. All right. So what I want you to do is, hopefully, if you understand that information, if you don't, rewind and listen to it again. I want you to go through yourself and answer all those questions, A, B, C, D, E, and F. All right. And probably before we get there, you can use this data to help you with the range and median and mode and all those summarising bits of data that we looked at in the last video. So for example, our range is going to be, our highest and lowest values, remember. So what's our highest value here? Okay, and it's not like the number of kids, it's how many pets they have. So the most number of pets a kid owns is 8. Okay, so that's our highest value. And look, if we're going to arrange this data, for instance, numerically we'd do 0, 0, how many have we got? 1, 2, 3, 4, 5. 3, 4, 5, 0, 0, 0. Then we've got all those ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I drew, 10 ones along here. And is that 3, 4, 5, 6, 7, 8, 9, 10. Then we've got 4 2s. So if this continued under here, I'd 2, 3, 4. We've got 2 3s, and then we've got an 8. There's all our data. So our highest score is 8. Our lowest score is 0. So you use those two values to calculate your median. Sorry, your range, not median, your range. All right, but I want you to try and work through this, and we'll come back and obviously go through it, but I want you to see if you can answer some of these questions using just the graph, rather not this stuff, okay, and I'm actually going to get rid of all that, so you can't do it. So you can go back and just use the graph to see if you can answer like the modes and the ranges and the medians and stuff like that. All right, so no more yakking from me, I just need you to get into it, so pause the video now and off you go. Okay, so hopefully you've paused the video. So let's go through some of these questions. So use the graph to state how many children have 2 pets. So how many kids have 2 pets? So here's 2 pets, and we've got 1, 2, 3, 4. So your answer should be 4. Really simple. How many children participate in the survey? Well, we've got to find out how many dots all up we've got. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there's 22 dots. Each of those dots represent number of kids, so we've got 22 kids that have been surveyed, and there are all our results. So 22 is the number of children that participated in the survey. Our range, so like I said, if we arranged all that, 8's our highest value. All right, so if I was going to show working out, I'd say range equals my highest value minus my lowest value, which is 0. So my highest value is 8, my lowest value is 0, which equals 8. So my range is 8. Okay. So 8 on that one. What is the median number of pets? So median means the middle number. All right, so we've got 22. Now remember, to find the median, we've got to find the middle score. And how do we find the middle score? So if we're going to find our median, okay, we do 22 plus 1 divided by 2, which is 23 divided by 2, which is, what's that? It's not 12, so it's 11.5. So our median score is between 11 and 12. So 11th and 12th score. So we work from the bottom and count up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So it's between these scores. Now these scores are 1. They're all 1. So it's between 1 and 1. So I could do my 1 plus 1 divided by 2, which is 2 divided by 2, which equals 1. But we should know that it's between 1 and 1, so it's got to be 1. So our median value here, their middle score, is going to be 1. Okay, so that's our middle score. So you're just using the data in the graph to work that out and just counting up from the bottom. That gives you your data, then you can find your median. So what is the outlier? Well, sort of explained that earlier. So our outlier is 8. Okay, so that's our outlier. And what is the mode? So it's the score that happens the most. We'll look at the graph here. This little guy. Okay, so the number of children that have one pet has the most scores, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Happens the most. So our mode is 1, not 10, because that's just telling us how many children have just one pet. So our mode, though, is 1, because that happens the most. Okay, that score of 1 happens the most. Okay, so hope that all makes sense to you. All right, so it's pretty easy using your graph, just thinking about it, thinking it through, you can get your correct answer. All right, very, very quickly, because we're nearly at 12 minutes, you need to construct a column graph. Okay, so you've got to make sure you've got, I'll try that again, slow down. Draw a column graph to represent the following people's heights. So we need our title. Oops, dear. Hang on, that's why, bear with me. No, I need that one. Okay, let's try that again. So people's heights. Oh, geez, this writes worse and worse, I reckon. So people's heights. Really badly done as our title. Okay, we're going to have height in, centimetres. On this column. Oh, not this column, on this axis on this side, so it's going to be in centimetres. And down the bottom we're going to have people. Okay, so I'm just going to do their initial of their first name. Okay, so we've got Tim. I'm going to leave a space just so it's nice and clear, and then Phil, and then Jess, then Don, then Nairi, I think it is. Okay, so I'm going to split them up. I'm just going to leave a space. You don't have to, but I'm just going to leave a space in between each of these just to make it a little bit easier and clearer to read. All right, so I want you to do this on your own note-taking sheet. I want you to now just use a ruler and a pen or pencil, and I want you to draw the column graphs. Once you've done that, come back and we'll have a look and compare. Okay, bye-bye. Now, actually, before you do go, probably one thing I need to say is, or need to talk about again, is our scale. Well, I've just changed to red. Okay, so we've got to look at our scale here. So I'm not going to go up by ones, obviously. If I went up by ones when we've got 150 centimetres, that's going to, we just don't have enough room. Okay, so let's think about, we could go up by tens if you wanted to, so 10, 20, 30, 40, but again, that's fairly, it's going to be fairly big y-axis there to go by 10, so maybe 20s might be the easiest way to go up. We could do 30s, but looking at a graph, probably 20s is the best way to go, and that's what I'm going to do. So I'm going to go up by 20s, and hopefully I've got enough room. So 20 at that mark, 40, 60, again not working very well, 80, 100 to that point, 120, 140, what do we go up to? 150 at the most, so I'm going to go up to 160 centimetres there. Okay, so right now I want you to transfer that information onto your own graph, and then I want you to actually draw the bar graphs for each one. Once you've done that, come back and we'll compare. All right, off you go, Neil. Okay, so welcome back, and let's have a look. So I've done these while you're gone, to rip through this really quickly. So let's have a look. So Tim had to be 150 centimetres. Okay, so if we're up to 140 there and 160, 150 has got to be halfway. So just draw a column in Tim's column here up to 150. Fill the same thing. So fill up to 120 centimetres up to this point, so equal to 120. Jess up to 140, so up to 140 mark in centimetres. Don up to 100, and then Nairi up from 0 all the way to 130, which is between my 120 and 140, so 130 in there. So nice and easy. So that's where the scale is important, because even if I had gone up by 30s here, so 30, 60, 90, trying to get accurate, accurate measurements for 130, your 100, your 140s, 150, 120 would probably work, but these other three would be a little bit more difficult because you're going up by 30s. But going up by the 20s, it's very easy to sort of get pretty equal to halfway. Obviously, the smaller the scale you create, then the more accurate your data is going to be. So if I went up by ones, for instance, like in science when we talked about scales and which ones are easier or more accurate and less accurate. So the ones with the smaller increments make it obviously a lot more accurate. Okay, so we'd have an estimate here that might be 150, but we could have had data that was 152 or 153 or something like that. Using a scale like this would make reading that really, really hard, and you wouldn't get an accurate reading. Okay, so it is sort of this particular scale, we're making a bit of an estimate of what it is. All right, so just keep that in mind, but in this case, so do think about your scale and what works the best, and maybe what's the easiest way to mark your measurements out. So you've got to look at your data first before you do that. All right, that is it. We've gone a bit longer than I wanted, 16 minutes, but anyway, we got through that. Quick joke before we go. Why couldn't the bicycle stand up by itself? Because it was too tired. Too tired. Yeah, I don't think they're getting any better, but I'll keep swinging them out there anyway. A little bit of a swing and a miss, but it's all good. It's all good. All right, thank you guys. Hopefully that all makes sense. Not overly difficult. Come and see me if you didn't. Re-watch the video for any parts that you didn't get. Talk to me if it's really well and truly over your head, but I doubt that will be the case. All right, thank you guys. Bye-bye.